Then are you doomed?
What do you mean, then are you doomed? How did we get to doom?
Well, because then you can't breathe in your spaceship. Do they have to wear helmets the whole time? Or they take their helmets off in a spaceship? I know so little about space, Ryan.
Okay, all right.
Hi, I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to Lesson 54. This week, we are answering another listener question. And Cheryl, I don't know if you remember, but we've actually answered a question from this listener once before.
Yes, this listener is a friend of ours, and he sent us a whole slew of questions a long time ago. And we did answer one of them back in our biology unit, I believe lesson 19, about why some birds couldn't fly, which was really fun.
Yep.
And what was fun too about his list of questions were there were all sorts of different fields of science, really. So we kind of had our pick, and you were really excited for this one. This one makes me a little nervous, if I'm being honest with you. But let's hear it.
All right, let's hear the question from Jeremy Heyman.
Hey, Ryan. Hey, Cheryl. So I've got a space question for you guys today, and that is, what is the vacuum of space? Because as far as I understand it, space is nothing. There's just nothing up there. But when I think of a vacuum, it's sucky. And when you see people like open up an air hatch or something in space in movies, everything gets sucked out. So why is space sucky and vacuumy? That's my question. Thanks. Bye.
So the question is, what is the vacuum of space? Also known as, why is space sucky?
But actually, Ryan, one of the things I remember from a science class is that my science teacher was very proud to tell us that science doesn't suck. Which I don't remember the ins and outs of that, but pretty much there is no such thing as something doing like a sucking motion in science. I don't remember why. Do you agree that science doesn't suck?
I mean, I agree that conceptually science doesn't suck, yes. But I think, and I've heard that distinction made by science teachers before, and I understand the reason for it. I don't know that it is as necessary to draw a hard line on that particular issue for me personally, but I understand why some people would do that. But let's get into the pre-assessment here,
Yes.
Cheryl.
Yeah.
Why does space suck?
Well, I mean, I think that's the movies.
Okay. What do you mean?
Well, because he was saying like in the movies that happens, that it's like, but then he was saying like a vacuum is like that too. If like space is like a vacuum, but vacuums suck. But I don't know if space does suck.
Okay, well, let's take a step back. What do you think
Yes.
a vacuum is?
Well, I use it to get the cat hair off my carpet.
I knew that's where you were going first.
Yeah, of course. I think about vacuum sealing. Like
Okay.
vacuum sealing, where like the absence of air. Is that what
Okay.
a vacuum is?
Okay.
And not like letting in more air.
Okay. So based on that definition, do you think space is a vacuum?
Well, I don't know, because I always thought space was really, really cold.
Okay.
But then one time I mentioned that to my husband, and I think he was saying like something different about, now I don't remember the details of that. But like space feels like this really giant question mark to me, where like
Okay.
I know it's the absence of an atmosphere, because
Okay.
like we on Earth and on other planets, you have an atmosphere where then you're experiencing like the weather or
Okay.
different temperatures during different times of year, or wind,
Okay.
all sorts of things like that. And so is space the absence of all of those things? Like, there's not going to be seasons there, obviously, because seasons are dependent on us being on our planet and like what our planet
Mm,
is doing or where it is compared to the sun at different times of year, things like that. So like
mhm.
but wouldn't you still be the same temperature if you like launch your little body off of Earth into space? If you're the same distance from the sun as Earth is, like, would you not be the same temp? So I'm curious about the temperature. I know we're talking
Okay.
about the vacuum of space, but I would like
Mhm.
this addressed.
Oh, okay. I feel like there's a little bit of a demand built into this lesson. Okay. All
Well,
right.
because I realize I really don't know. Like, what would it feel like if you were just out there? But would you suffocate? Astronauts
Okay.
wear helmets. Is there
They
not
do.
air because there's not an atmosphere? So there's not like breathable.
Okay.
If it is a vacuum, is it a lack of oxygen?
Okay.
And then I've also heard, and I don't remember what context I've heard this in, but like if you were in space and you like pushed off of something in a direction, there wouldn't be anything to slow you down. So you would
Mm.
just keep going because Newton's law wouldn't apply. Is it Newton? Did I do it right?
It is Newton, but it's not that it
Yes.
wouldn't apply. It's that it would apply actually, but we can get to that later.
It wouldn't apply in the same way.
It actually applies in exactly the same way.
Oh, because it just, yeah, okay. So,
But-
like, is that to do with being a vacuum? That there's like no
Okay.
elements
Okay.
slowing you down because it's just
Okay.
nothingness?
Okay. No elements slowing you down. Okay.
But then he was talking about the movies. What was he saying? Like, if a door opens, there's a whoosh?
Yeah. Or oftentimes, yeah, when you open like a door out into space, things get sucked out.
Okay.
That's why he said space is sucky, because it like sucks things out.
Well, if that's true
Mm-hmm.
in like real life in space,
Mm-hmm.
would that just be because if there's no air in
Mhm.
space and there's air inside of your spaceship,
Uh-huh.
then that's gonna be like a really big pressure change
Okay.
really quickly, right?
What do you mean?
Well, if there's air in one place and air not in another place, and all of a sudden those places are the same, then the air is going to move really quickly, which is going to create a lot of pressure or like wind for a second.
Okay, it's going to move
it
from where
moves.
to where?
Ooh. It's going to move from in the spaceship to out into space. And then inside of your spaceship will also be a vacuum at that point.
Mm. And why would you call it then a vacuum in the spaceship at that point?
Well, it's got to be the same inside and outside if you have a door open. Like, it's all going to become the same situation.
Okay.
But then are you doomed?
What do you mean then are you doomed? How did we get to doom?
Well, because then you can't breathe in your spaceship. Do they have to wear helmets the whole time? Or can they take their helmets off in a spaceship? I know so little about space.
Okay. All right.
Do you need like a breathing situation like the entire time you're on your trip to the moon? Or do you get to take it off inside of your spaceship?
Okay. I think I'm going to pause us here for a moment as far as the pre-assessment.
Okay.
Because here's what I think we're going to do here in just a few minutes.
Yeah.
I think I'm going to answer Jeremy's question.
Okay.
And then I'm going to come back and answer all of the other space questions that you've asked.
Great.
Because there's been a bunch.
So I probably just derailed everything Jeremy was asking. Or he's I know all those answers. I just want to know about the vacuum part of it.
Maybe, but you did keep trying to come back to the vacuum part.
I was trying.
You did try. And we will for sure answer Jeremy's question, and I will do my best to answer your other little questions, but it will probably spark more questions from you, but I'm not going to answer those questions. You're going to have to write those down for future unit.
And then, Ryan, we will do a unit on astronomy.
Yay! That will make me really happy. All right, let's just start with what is a vacuum, and then
Okay.
we'll work our way through to the best of my ability.
Great.
Okay. Your description of a vacuum is pretty accurate. You use the example of vacuum sealing, and you said it's the absence of air. And yes, that is basically the way that we would describe a vacuum. We would probably describe it in astronomy even beyond just air, but just the absence of matter. So whether it's
Okay.
specifically from air or not, but just there's no matter. So if you have something, a container or an area that doesn't have any atoms in it, you would call that a pure vacuum. Now, technically, there are lots of things that aren't actual pure vacuums, but that are effectively vacuums. Like, I don't know if you've ever heard of like a vacuum chamber or anything like that.
Yeah.
You can hook up like an air compressor to a container as long as it's reinforced enough and doesn't have seams where air can get in. And you can suck out most of the air so that it's not technically a pure vacuum. There's still technically some molecules in there, but it's low enough that it functions like a vacuum.
Okay.
Does that make sense?
Yeah.
Okay. So yes, it's the absence of air, or at least very, very low concentration thereof. Okay?
Okay.
We're good so far.
We're good so far.
Okay, great. And so then you also talked about whether space was the absence of changing weather and changing temperatures and winds. And I'm going to say yes for some and no for others.
Okay.
Weather is all based on air. So you have to have air in order to have weather. Now, it doesn't necessarily have to be air in the same sense that our atmosphere, it doesn't have to be the exact same mix as our atmosphere, but you have to have a mix of gases, and you need to have what we call uneven heating, where part of a planet or moon or whatever the object is heated more than another part. And so those gases mix to try and even out those temperatures. And that's what creates weather. Again, big simplification, but trying to get there. And so wind is that same thing, the air moving from one place to another. Temperatures, however, are a little bit trickier, especially depending on how you want to talk about temperature. But I'm going to put that in a side category, move it over to the edge. We will come back to it in a few minutes. Okay. And if I forget, just remind me. Okay. So we'll come back to temperatures. What you described as far as why, if you're in space, if you open the door, that all the air would rush out is exactly right.
Heck yeah, it is.
Okay. The one piece that I would add, only because we've talked about it in previous lessons, so to try and make those connections for you, is that air, just like most things, is going to go from where there's a higher concentration of it to where there's a lower concentration of it. I know we've talked about it a couple of times. The time that I can remember the most is when we talked about brining a turkey. Remember we talked about water?
Disbursement.
Diffusion.
But we talked about dispersing.
We did, but that's disbursement is not a science term. So
okay.
I don't know where you got that word from. I think that's the word that you put in your head to describe whatever it was that we talked about.
Yeah, probably was.
Yeah.
Diffusion.
Diffusion. Yeah. Diffusion is going from higher concentration of something to lower concentration of something. I think I use the example of like Axe body spray, right? You spray in the front of the room and eventually it gets to the back of the room. That's diffusing. It's spreading out. So that's essentially the same thing. Now with air, it's working for slightly different reasons, and it really comes down to pressure. Air is always pushing in all directions. And we talked about that one too when we talked about a balloon like floating and sinking, right? That the air or any fluid is actually pushing in all directions at all times. That includes on like a door or on some sort of solid surface. The air is bouncing, the molecules are bouncing off that side. Here on Earth, the other side of whatever our surface is usually more air. So it's equal, it's balanced, it doesn't matter. But if you're in space, where on the other side of that door is not air, it's a vacuum, Now you've got all of this air pushing against this door. And if you open that door, it can all get pushed out. That pressure is pushing it out that door. And that's why your science teacher said that science doesn't suck, because technically the force is coming from inside pushing outside. It's not the outside sucking it out, if that makes sense.
So it's pushy.
It's pushy. Science is pushy, yes, but it's not sucky. So that's kind of where that comes from. But yes, so, and that is true. And depending on how pressurized it is and depending on the size of the opening and all those things, it can be essentially explosive in nature when that happens sometimes, where you can actually, like, if you started to open the door, it could like blow the door the rest of the way off.
Like a champagne bottle.
Yeah, because that's under pressure. Yeah, and like you start to loosen the cork and it goes, right, and pops all the way out. Exactly, because there's enough pressure inside. You're exactly right. So I think that answers Jeremy's question. Do you feel like that answers Jeremy's question?
I'm going to speak for Jeremy and say that yes, it does answer his question.
Okay. And since Jeremy is a regular listener, if not, I'm sure he'll let us know. And we can do a follow-up lesson. Okay. So yeah, that it really has to do with that difference in air pressure. And that's why space is sucky. And that's why space is a vacuum, because it doesn't have that air. The only reason we do have air on Earth is because gravity holds all of those molecules around the planet. But if you're out in the middle of space, which most of space is empty, there's nothing to hold any of those molecules together. So they spread out and they get really, really far away from each other. And that's also why when I said technically like a vacuum, space technically has some molecules in it. They're just so spread out that it's effectively a vacuum. This also gets back to your question about temperature. Remember, we set it to the side and I said to bring it back.
Yep.
Okay. And you asked about whether space is cold or not. And you said someone at some point had told you that it isn't, or it is, or something.
Yeah.
I don't.
Yeah.
What?
I thought it was cold at one point, and then I feel like maybe I heard it. What? I don't know.
So the challenge is how we talk about what it means to be a particular temperature. If you remember back to our hot and cold units, we talked about temperature is defined as, do you remember?
Is it energy again?
It is a form of energy. Yep. It's the energy of molecules. And so the faster the molecules are moving, the higher the temperature, because they're bouncing off of whatever surface is faster and harder. Does that make sense?
Okay. Yes.
Okay. So as you go up in our atmosphere, it tends to get colder.
Yeah.
But the air also tends to get thinner. And so when you get into space, there aren't molecules to run into you because it's a vacuum. So in a sense, there's no temperature. But that's not the same thing as a temperature of 0, because if temperature is the speed of those molecules and there just aren't molecules, then it's not really cold, but it's also not really hot. And in some senses, the molecules that are going through space are usually moving very, very quickly. So if you just took the temperature of that one molecule, then like the energy of that one molecule, then the temperature would be really high. But there's only like one molecule per, I'm making this up, one molecule per, let's say, cubic meter. So then if you do the average, well, there's only one. So the average of one is itself. But effectively, your body isn't being hit by that. So it's not a high temperature. So do you see where it gets fuzzy?
Yes. Yes. So, but if I were in space, would I suffocate or freeze first? What would kill me first?
Which would kill you first? Okay, if you were in space, you would die for lack of oxygen first before you would freeze. Because your body has heat and it would be radiating that heat out. You would feel cold because...
Would I feel like very cold?
You would feel pretty cold. Yeah. Okay. Because there's even in the air, there's still heat in the air. All of the molecules of the air have energy. They're running into our bodies at all times and helping transfer that energy. There would be nothing running into you. And so all of that heat would radiate away from you and not be replaced by anything at all. And so you would lose that heat fairly quickly as you radiate that away. But you can only last a few minutes without oxygen.
Yeah. Yeah. Okay.
Right. So, and you've got enough like energy, like, yeah, you wouldn't just immediately freeze. And that's a whole other thing, is like, how would you die if you went into space or whatever? And we could talk about that as another question at some point if you'd like to, because there's so many ways you could die. It's very exciting. But you're right. There's not breathable air. There's not really oxygen. That's the part that is breathable for us. The part that we need, right, is the oxygen gas, and it's not really there. But you were also wondering, like, what about the astronauts when they go up into space? Do they have to keep their helmets on the whole time?
Yeah.
Well, they would only need to keep their helmets on the whole time if they were in a vacuum the whole time.
Yeah.
Right? If they were in something without the oxygen. But the spaceships are sealed, they're airtight, and they have oxygen generators and carbon dioxide scrubbers so that they can generate the oxygen and they don't have to have their helmets on. Typically, I believe they do keep their helmets on during like liftoff and then during re-entry, because in case something happens and there's some sort of like puncture or something and they lose pressure, then they've already got their helmets on as like a backup safety measure. But
and then they would die from the fall, but not from the lack of oxygen.
Well, if they were falling, yes. But if it was just like a puncture, but everything else was still working, like the parachute still worked or whatever, then they wouldn't necessarily die by that. But they could. I vote for no, but yeah. So that could be. And then let's talk about Newton's law. Okay. So I think this is the last extra thing that you talked about. If they were to like push off from something and they would just keep going.
Would they go infinitely?
As long as they don't run into anything else, there's no other gravity thing close by, like a star or a planet or a moon, then yes. But that doesn't go against Newton's law. That actually is the perfect example of Newton's law.
Oh, because objects in motion stay in motion unless there's some
outside force. Exactly right. Exactly right. But we don't usually encounter that here on Earth because there's almost always an outside force, and that outside force is usually friction.
Yeah.
And there's friction even, and you reference this, even from air. And so you even talked about that, like there's no air to slow you down. And that is accurate. There's no air to slow you down if you're not rubbing against a surface, right? So it's not that there's technically no friction in space, although that's the way people often talk about it. Like if you were in space and you had a suit on and you took your gloves and you rubbed them against each other, there would be friction there. So it's not like there's no friction in space. It's just that the space itself does not have something to rub against to cause friction like here on Earth, right? Like you take your hand and you move it up and down really quickly, you can feel the air.
Yeah.
Try it.
I feel the air.
Okay, great. Right. And that's friction. There's friction between your hand and the air. You can feel it. And it's there all the time. We just don't usually notice it until we're moving fast enough. But like so it's there. But that doesn't exist in space because there's no air in space. So that won't slow you down. There's not gravity, any of those things. So that's why, yes, if you were to push off, you would keep going because there wouldn't be that outside force.
And you couldn't like swim back because the reason we could even a tiny bit use the air, like get back, it's the same as like a bird flying with its wings. But I'm thinking, I'm picturing if you're in a rolly desk chair and you're trying to get back somewhere, you could, but you can't do that if there's no air, right?
Right, because in a rolly desk chair, there's friction between the wheels and the floor. So there is still friction somewhere that allows you to do some pushing off. Yeah. If you want to see a really good example of something that I actually think is fairly accurate of how it would work, watch the scene in WALL-E with the fire extinguisher.
I love that scene.
It's a great scene. And I loved it. One, because it's just beautiful and the way it's done is great. But it's also the physics in it are pretty accurate
Oh, cool.
as far as like just kind of keeps going and has to like shoot the fire extinguisher in the opposite direction to like change his direction or slow himself down or whatever. So now you have an excuse to watch Wall-E.
Okay, great. Well, Ryan, I have now learned an easy way to tell how excited you are about the topic that you're sharing about.
Okay.
And I'm
What did you
curious if
learn?
our listeners picked up on it or not. It's your level of clapping.
Clapping? Did I clap
You
during this
were
episode?
clapping a lot to tell me the points that you were making because you love astronomy so much.
I'm so sorry. I feel like that's super annoying. I apologize.
I almost was like gonna tell you to edit it out and not edit the clapping out, but be like, hey, stop the clapping, edit out this pause where I tell you to stop the clapping. And I was like, no, it's more
It's
fun.
funnier if you leave it in and then can make
Oh.
fun of me at the end. Got it. Okay.
Yes, absolutely.
All right. No, I was definitely unaware that I was doing that. So
It's
good
your
to know.
genuine enthusiasm, and I love it. It's so exciting. It's part of
My
what makes this podcast
enthusiasm-
really fun.
Well, I'm glad you enjoy it. So my enthusiasm is getting very, very clappy, apparently.
But you're not clapping back.
Oh boy. Well, okay. With that in mind, it's time for your quiz.
Okay.
Alrighty. First question. Are movies accurate when they show things being sucked out into space?
They sure are.
Okay, great. Question 2. Why do things get sucked out into space when they open a door or a hatch?
Diffusion.
Please
It's
explain
the
in more detail.
pressure change because the air in a higher concentration or anything in a higher concentration when given the opportunity will move to the area with the lower concentration, and when it is like large difference it will happen very quickly, or
Mhm.
even if it happens the same speed it will be more noticeable, like a big suck or a push, a big
Mhm.
boom,
Okay.
like a champagne bottle.
Okay. And connect that to spaceship and space.
Inside of the spaceship is breathable air. So there's enough air in there that it's breathable. And there is almost no air in space
Okay.
that we can effectively call it a vacuum. So that is a high difference between those two places.
Okay. And therefore,
it will seem like everything is being sucked by space out of the spaceship like a vacuum.
ooh, I love the motion you did there too.
Yes.
It's almost like a squid.
Yeah.
You have to check this out on YouTube if y'all want to see exactly what that looks like. Okay. Question 3 is a very important one. Why doesn't science suck?
Because you're a science teacher and you say so. Because technically it is being pushed out, like the air or anything that's being in the high concentration is
Mhm.
being pushed into the area with low concentration as opposed to sucked into that area.
Okay, great. And why would you move forever if you pushed off while you're in outer space?
This is the most important question. Not related to what Jeremy was asking.
No, it's not.
Because there isn't anything that would cause friction, and friction would be typically what would slow you down if you pushed off into eternity. Also, if you pushed off with nothing, gravity would just cause you to fall on your butt. But then on top of that, even if you were like sitting on a skateboard, you wouldn't continue to move forever because of the ground, because of the air, because of so many things on Earth that are not
Yep.
in space.
Yep. The only thing I would add is that there's no outside force to oppose your motion. So whether that's friction or gravity or some other something.
Oh, mhm.
Right. Yep. Great. And the final question is space cold? Justify your answer.
Well, technically. See, I'm going to say it's cold because I think about cold as far as if I feel cold because I'm very self-centered. And so
Ah.
I would say that it is cold because you could freeze to death.
Okay.
So like and that's, I don't know, it would, if you brought water, it'd probably turn into an ice cube too, I'm guessing. Would it?
No, the ice cube. No, it would.
Or would water just go everywhere?
It would. I think it would sublimate. I think go straight to a gas form because there's also no pressure.
Okay,
And
interesting.
pressure has an impact on solid, liquid, or gas, not just temperature. I don't remember if we've talked about that before or not.
No, but we have talked about sublimation. I remember that.
Yes, when we talked about dry
Interesting.
ice. Yeah.
Cool. Okay, so no popsicles in space. But yeah, I would say even if you wouldn't, not on like a measurable level, it is cold as far as like the temperature is cold. I think if you can freeze to death somewhere, that you can call it cold.
Okay, great. And I would have accepted either yes or no, depending on your justification.
Ooh,
So-
fancy.
I know. So nice job justifying. As one final side note, I'm trying to remember which one it is. In one of the Guardians of the Galaxy movies, I think it's the first one, where Star-Lord like is out in space and like takes off his helmet and gives it to Gamora. Is that right?
I've seen it once. So
Okay. Someone is yelling at their listening device or watching device right now saying, no, it's blah, 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 blah. And I apologize. But anyway, when he takes it off and like you see him kind of like freeze and stuff like that, that is a relatively accurate depiction of what would happen. Like what you see.
Oh, cool.
So, not completely, but relatively speaking, it's not so like off the charts wrong.
Wow.
So,
So that movie is scientifically accurate.
that is not what I said.
is.
And on that note, why don't you pack up your stuff and get ready for my closing remarks? You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.